All right, so we're going to look at the lesson A4 today, day 1. We're going to solve log equations this time. So a logarithmic equation is an equation with a logarithmic expression that contains a variable. And so what we talked about yesterday was an exponential equation where I had to convert it back to its log form to bring that variable down to kind of that base level. And so you may be wondering, well, why can't we just kind of use our calculators to solve something that looks like this today? Well, that's because I have the variable within that log, right? I don't have just log 4 of a number and my x is over here. We've already done stuff like that. That's whenever we solved those basic log equations earlier in lesson A2. The variable is now kind of in that log. We're going to have to do something different, right? So hopefully you can see the difference here. We had just log of a number, log of a number. We could use a calculator. You can calculate the log of a number, but it's going to be different. We have an x. So we have some steps that we're going to use to follow when we have a logarithmic equation like this. So the first thing that we want to do is condense one side to a single logarithm using the properties of log. So basically, kind of like how we would say, get your x on one side, we're going to do the same thing. Get your log on one side. Condense it to just one log. So this is why we talked about the expanding and condensing. We want to be able to switch back and forth depending on what we need. Then we're going to convert it to its exponential form. So it's, again, the opposite. Whereas the exponential equations, I had the variable in my exponent, I had to convert it back to log. We're doing the same thing. The opposite of a log is to take it back to its exponent form. We're doing the inverse. So we're going to take it to its exponential form there. Then we can solve. And just like those radical functions, we have to check for extraneous solutions. Answers may not create the log of a negative number. So just like how, and we're going to see the same thing today. We're going to see that quadratic function appear within this log function. But remember, that log function does not follow or abide by the rules of your quadratic. So by using a quadratic way to solve, once we kind of use different, we apply these properties, we're going to have to check to see, because one of those answers may not actually work out. Why can't we have the log of a negative number? Let's just think about this, right? I don't know. Let's say I have log of, base, we'll just stick with base 10, so I don't even need anything. So log of negative 4 equals 2. So remember, we can convert that back here. We can say that's really 10 to the second power equals some negative number. This is never going to, I know this doesn't make any sense, but we can't have this, anything raised to a power that's this positive base right here, because we can't have a negative base as my log. Anything raised to a power is always going to be positive, unless if it's cubed or to the fifth, or it's an odd power and you have a negative in front. But we won't ever see that. You won't ever see a negative base here. So basically, you can't have a negative here, right? I know that example mathematically made no sense. I probably should have used a variable in there somewhere. But you can't have a negative, so we cannot do this. No negative number within your log. That defeats the whole purpose of it, right? You can't raise a positive number to a power and then get something negative. That's not going to make sense. So we can't do that. Okay, so let's just go ahead and start here. So the first thing that I want to do is convert it to its exponent form. So this is why we practice that rearranging. So remember, this number is my base, this stuff is my answer, and it's equal to my power, right? This whole thing is equivalent to what your exponent is. That's what I've been trying to say this whole time. And so we can rewrite this as 4 to the third power is equal to x minus 1. And so we've successfully gotten rid of the x from being a part of the log. It's now back to that ground level. It's not attached to the log. We're good to solve. And so I can simplify here. 4 cubed is equal to 64. That's equal to x minus 1. I can now add 1 to both sides to finish solving here. So I get 65 is equal to x. And there would be my answer. Now we can always, again, check. Okay, so I can... I know we don't have more than one answer here, so it's kind of like how we did the roots. You really only have to check if you have more than one answer, right? But we can just, double check here. If I plug that 65 back in for x, 65 minus 1 is 64. I'm taking the log of a positive number, so we're fine. We know that this is my answer, right? I only have that one, so we're good there. Okay, so then let's go ahead. And you can always type this in your calculator. If you type in, well, I know we can't type in base 4. Some of you can if you have the fancy calculator, but, You can always check it if you need to. All right, let's move on to the next one. So I want to again convert it to its exponential form. So this is my base, this is my power, this is that answer part, or what we're setting it equal to. So this is really base 2 raised to the negative second power. That's equal to x over 8. And what does 2 to the negative second power? What can I rewrite that as? All right, hopefully you said 1 over 2 squared, which is 1/4, right? You can bring that down to the denominator. So 1/4 equals x to the 8th power. And now we have kind of an ugly equation, but we can do it. Just look over here. The operation that we need to do to get rid of that division is to multiply. So we can multiply by 8 on both sides. So I have 8 times 1/4, which is 8/4, which is just 2, right? 8 divided by 4 is 2. And we can again plug that back in if we need to check. 2/8 is still positive, 1/4, that's positive. So we know this is going to be my answer. So again, please, please, please do not forget your negative exponent rules, because that comes in handy a lot when we're dealing with those fractions and we need everything to look like an exponent. Okay. And so now this one looks different than the others because we don't have just one log. And so that was my initial step here. I need to condense one side to a single logarithm, which is why we practice expanding and condensing. And so how can we condense this into one log? All right, hopefully you said log 4x. Because if they're being added, its condensed version is multiplication, right? And so log 4x equals 3. And so now that I have this, remember this is invisible base 10, so I can take it back to my exponential form. So my base is 10 raised to the 3rd power is equal to that answer part of 4x. And I can simplify. 10 cubed is 1,000. Equals 4x. I can now divide by 4 on both sides. So I get x equals 250. So I will say on the homework and for these notes, your numbers are going to be all over the place. You can have fractions. You're going to have high numbers. Like one of them I think is like 200,000 or something. Like you're going to have big numbers. So don't be surprised, especially because we're dealing with exponents, right? We can get to large numbers very quickly with exponents. Don't be surprised if you see a large number. Okay, so then this one here, sorry, my iPad is still being weird, even without me being connected to the iPad. How would we condense this to a single log? All right, hopefully you said we could take x times x plus 5, right? Those things are being multiplied together to create that one condensed log because they're being added together. And so I would go ahead and even simplify this before you rearrange. That's just me. You can simplify it after you rearrange, but we really have, this is log of x squared plus 5x equals 2. And so now I can change everything. So this is my base. So I have base 6 raised to the 2nd power is equal to all of this stuff here, x squared plus 5x. And again, I could simplify. So I have 36 equals x squared plus 5x. And now you're probably thinking, hey, this looks familiar. We did this kind of with the roots, right? But again, we didn't start with a quadratic, so we're going to have to check for those extraneous solutions, but we're going to solve it the same way. We need to get everything on one side. I need to set this equal to 0, so I'm able to factor. So I have x squared plus 5x minus 36 equals 0. And then I can solve. So I have negative 36 and then 5. Okay, so then we can factor this, right? My two numbers that multiply to negative 36 and add to 5. Negative 4, positive 9. 9 minus 4 is 5. Those two multiply to negative 36. And so then we can put them in my factors, right? X minus 4, x plus 9 equals 0. Therefore, my two answers are 4 and negative 9. And since we have two of them, we definitely have to check here. So I can just pick one. If I plug this 4 in for x here, yes, I have the log of a positive number. That's good. If I plug my 4 in here for this x, I would have 4 plus 5, which is 9, so that's also positive, so we're good on that one. And if you can already see here, if I just plug negative 9 in for this x, we are not going to get anywhere, right? We can't have the log of a negative number there, so we can just cross this one off. I will say about 9 out of 10 times your negative one usually is going to be the one that you're going to cross off, but I don't want to give you a 100% guarantee, right? It's not always the case, but usually maybe start there and plug it in to see if usually that's one you can cross out. So my answer is just 4, okay? So hopefully that went okay. You'll be able to do the homework. I'm going to make an optional homework video going over example 9 that you can watch. It's not on Edpuzzle. So that way you're not obligated to watch it and you can skip around to what you need. But other than that, have a great weekend. I will see you guys on Tuesday.